Okay, good morning. We're working on areas and volumes of similar solids, and we're taking notes on that. This will be your homework right here, T7 and T8 in IXL. So make sure you're working on that. Okay, what we've talked about before is scale factor, and scale factor is just A over B. And then we took that and we found area ratios, which was A squared over B squared. We've already learned that. Today what we're looking at, something new, is we're looking at volumes. And what we have for volumes is, just like volume is cubed, the ratio will also be cubed. This is in one dimension, it's a distance. This is in two dimensions, it's an area. This is in three dimensions because we're talking about volume. So that's what we're learning new today. Okay, to do these real quickly, make sure you're getting this all into your notes, but you can figure a lot of it out on your own. Looking at these two, they are similar. 6 to 9, that's the scale factor. But that could be reduced. That would be what? 2 over 3. Now that we have the scale factor, we can use that to find the ratio of the areas. We just square it. 4 over 9. We can also use our scale factor to find the ratio of the volumes. 2 times 2 times 2. 8 over 3 times 3 times 3. 27. And we can use any of these ratios to find any missing thing that we happen to be looking for. Okay, got to go quickly here. Are the cylinders similar? Well, let's set up a scale factor. Their radiuses are 5 to 6, so we'll write that down as a scale factor. 5 to 6. Okay. Does that match up with the 10 to 12 ratio? Are those the same fractions? They are, so that means these shapes are similar to each other. Now, if this is the scale factor, what's the ratio of areas? You take this, and what do we do to it? Figure it out for yourself right now. Write it in. 5 times 5, 25. 6 times 6, 36. All right. That takes care of our ratio of areas. What's 5 times 5 times 5? That's the ratio of our volumes is going to be what? 125 over 36 times 6, because you're doing it 3 times. 6 times 6 times 6, 216. And depending on what our problem is, these are the ratios that we'll use with a cross multiply and divide to find our answer. Okay, pause it if you need more time, and then go on. All right. Two cones have a scale factor of 3 to 8. So their scale factor is 3 to 8. The smaller cone has a volume of 81 pi. So that's going to be down here in volume. So let's fill everything out real quick. Ratio of areas is going to be 9 over 16 or 9 over 64? 64. Okay. Then our next one, that would be 27 over what's 8 times 8 times 8? Write that again. 27 over 8 times 8 times 8. 512. Okay. Now, we've got all of our ratios. Now we need to decide what type of ratio do we need to use. The smaller cone, so we are dealing with two cones. The smaller cone has a volume of 81 pi. What's the area of the larger one? This is probably exactly what IXL will have. We're talking about volume, so we're talking about volume. We're using this ratio, and we set that up with 81 pi. We've got a small over large ratio, 81 pi over question mark. All right, we're in a cross multiply divide situation. So 81 pi times 512 divided by 27 equals, well, we're going to just plug that into the calculator, but don't times it by pi yet, because I think the answer they're going to want in pi. So 81 times 512 equals that divided by 27 equals 1536 pi units cubed. Now you could times this by pi to get a decimal. If IXL wants you to do that, do it. Otherwise, leave it in terms of pi. Okay, next problem. Let's see what we have. The lateral areas of two similar paint cans are 1,019 centimeters squared and 425. So we're talking about area. So we are starting with the ratio of areas. So 1019 over 425. And the thing is, these are not reducible, really. We don't have ones that are going to reduce nicely. So I'm doing harder problems than you're going to get on your homework. A lot of yours will reduce nicely. So to go backwards, we would have to take the square root. Square root of 1019 over the square root of 425. All right, now we've worked backwards to get to scale factor. Now let's take this and go back this direction. All we're going to do now is cube them. So here we now have the square root 1019 to the third power over the square root of 425 to the third power. Now we've got our ratio made. Now all we have to do is say, well, what's the thing that we knew? We knew the volume of the smaller can is right here. So take that. Where's our smaller can? Well, we did small can on the bottom this time, so it's 1157 down here. Now we're just going to cross multiply divide. And you may not be used to this right here, but you can type this into your calculator on the XNeat calculator just like this. So it would be 1157 times the square root 1019 to the third divided by the square root of 425 to the third. Okay, you might have to do that in parts or something, but the calculator can handle all that. Okay, put in your answer. That will be the volume of the larger can. Okay, next problem. Okay, farmer has a silo that has a diameter of 12 feet and a height of 20 feet. I want you to draw this. Use another piece of paper if you need to. He wants to build another silo that will hold twice as much. So your first step is find the volume. Find the volume of the first silo. Then there's this second silo here. Draw and find volume of silo number 2. That's the 24 by 40. Compare the volumes. He wants to build another silo so that it will hold twice as much. Find these two volumes and then compare them. Which silo, is this silo going to hold twice as much, or is it a different amount? I want you to design a silo that will hold the correct amount, twice as much as this one right here. So take your time, hit pause, work this problem out. Okay. I'm just going to grade you on that last problem. I'm not doing it for you. If the cone on top of the silo is 6 feet high, so you've got a cone at 6 feet high, it's going to look like this, it's going to look like this. How much steel will you need to build it? So this is going to be 6 feet high on a cone, but you don't know the slant height. And you need to get the radius from the last problem. How much steel will you need at the content of the silo? Let's flip back. What was the radius? Diameter is 12. So that means the radius would be 6. Come on. Alright, I'll go this way. Alright, so that means that this radius is 6 right here. So you need to first find slant height, and then you need to find the surface area, but it's a cone for a top of a silo. Do we need the base? Do you need the base on this shape? Remember, there's two parts. There's the circle, and then there's this kind of sector thing. This is the actual cone part. Does the silo, at the top of it, does it need both of these pieces? Yeah, this is all it needs. This is like the roof of your silo right here. We don't need the base part. So whatever you do for your surface area formula, get rid of the base part. So surface area of a cone, all you want is the pi RL part. All right, use the Pythagorean theorem, figure out what this is. This is one you're going to finish on your own. Okay, silo is on top of a cement pad that's a square, and it's 18 inches thick. So you're looking down. Your silo needs to be inside of this right here. So use your radius, and it needs to be larger than the silo. So it needs to stick out a little bit from the silo in every direction. So design a concrete pad that it can fit on, and it needs to be 18 inches thick. So you need 18 inches here if you're trying to make that a little bit 3D. So finish that one on your own. All right, that's the notes. Work on your IXL.